let's now proceed with the prediction of the products of chemical reactions. So, simple chemical reactions can be divided into the following classes. We have the combination reactions, decomposition reactions, single substitution or single displacement reactions, double substitution or double displacement reactions, and combustion reaction. So let's have first the easiest, or simplest form of reaction, which is the combination reaction. So combination reactions involve the reaction of two or more substances to form one compound. For example, if we treat aluminum metal with chlorine gas, the elements can combine to form aluminum chloride. So si aluminum plus chlorine will yield aluminum chloride. Ma'am, nga naman po kay bawman ta nga aluminum chloride nga maunay formula nga ma-form. Kaya again, aluminum, ang yang charge, positive 3. Si chloride nga ayon, negative 1. So, nga na, that is aluminum chloride. Nga na. Then, you balance. Again, do not forget nga, when dealing with chlorine, dapat na siya subscript nga 2. Kaya it occurs naturally as diatomic molecule. Then, you proceed with balancing. Okay? So, to illustrate, let's have example 4.6. Complete and balance an equation for the reaction of zinc metal and oxygen gas. So, we will identify first the product, if we have zinc and oxygen, so your product will be zinc oxide, So, ang charge ni zinc, positive 2. Ang charge ni oxygen, negative 2. Again, mo ng negative 2, kay oxygen belongs to group 6. 6 minus 8, that is negative 2. Then, exchange. So, you have ZN2O2 or ZNO. So, this is zinc oxide. Then, we will balance, So, zinc plus oxygen will yield zinc oxide. Okay, so 2 we will write here 2. Okay, para mabalance ang atong oxygen. To balance the zinc, we will write here 2. Okay, so this is now the balanced chemical equation. For every 2 moles of zinc and 1 mole of oxygen gas, it will yield 2 moles of zinc oxide. In another type of combination reaction, a compound may be able to combine with a particular free element to form another compound as the only product. This occurs most often when the free element is the same as one of the elements in the original compound. Okay, so for example, kini Cr is chromium, if I'm not mistaken. 2 moles of chromium 2 chloride plus chlorine gas will yield 2 moles of chromium 3 chloride. So in yet another type of combination reaction, 2 compounds containing the same element may be able to combine to form a single more complex compound. The element the reactants have in common is very often oxygen. So in this case, for example, magnesium oxide plus carbon dioxide will yield magnesium carbonate. So, si oxygen, mutapo ani. Okay, may mong carbonate. Or, for this example, we have calcium oxide plus water, kini siya mo doon will yield calcium hydroxide. So, mo na timanan ninyo. Isa nga timanan din yung class. Kung oxygen galing niya na ay water, ang ma-form niya is hydroxide. Okay, isa na siya timanan ninyo. Okay, that is for the combination reaction. Let's proceed with decomposition reaction. Decomposition reactions have the opposite effect from combination reactions. In a decomposition reaction, a single compound can decompose to 2 elements, to an element and a simpler compound, to 2 simpler compounds, rarely to another combination of products. Decomposition reactions are easy to identify because there is only one reactant. We have here table 4.1, which summarizes the most common types of decomposition reaction. Okay, so if you have a binary compound, pasabot a compound consists of 2 elements only, ang yang product will be 2 elements. For example, this one, 2 moles of water will decompose to give us 2 moles of hydrogen and 1 mole of oxygen. Then, pwede po nga ang isa ka binary compound will decompose into a compound and an element. So, for example, this one, this will decompose into water and oxygen. Then, if we have ternary compounds, so it can consist of 3 elements in a compound, pwede siya nga decompose niya, ma-produce will be compound and element, no, or two compounds. So for example, kini si potassium chloride will decompose to potassium chloride, which is a compound, and oxygen, which is an element, or pwede po two compounds, no. For the example of calcium carbonate, ma-decompose siya into calcium oxide and carbon dioxide. So decomposition reactions are often used to prepare elements. Joseph Priestley, the discoverer of oxygen, used the decomposition of mercury to oxide to prepare elemental oxygen and free mercury. Okay, so this is the chemical equation of the reaction described above. So that is for decomposition, kanang ning bungkag ni decompose, ni disintegrate by sakto nga term basta kay imong gibuwag, no. Let's proceed with single substitution reactions. So the reaction of a free element with a compound of two or more other elements may result in the element displacing one of the elements originally in the compound. A free metal can generally displace a less active metal in a compound. A free nonmetal can generally displace a less active nonmetal in a compound. So for example, we have copper plus silver nitrate. So magbaylo si copper ug si silver will form copper 3 nitrate and silver, no. Or for this one, no, chlorine plus calcium iodide, magbaylo silang duha, will form calcium chloride and iodine. So in this class of reaction called a single displacement reaction or single substitution reaction, elements that are inherently more reactive can displace less reactive elements from their compounds. Let's proceed with double substitution reaction. Katong ganiha single, isa ra gipulihan, kini double na, no, double na. So the reaction of two compounds may yield two new compounds. Many reactions that occur in aqueous solution involve two ionic compounds trading anions. This class of reactions is called double substitution reactions, double displacement reactions, or metathesis reactions. Note that in aqueous solution, neither carbonic acid nor ammonium hydroxide is stable. They decompose to yield water and carbon dioxide or ammonia respectively. So if either carbonic acid or ammonium hydroxide is expected to be a product of a double substitution reaction, kinahanglan nimo siya i-disintegrate or i-decompose into carbon dioxide and water or ammonia and water. Again, if ganing, no, magkuan na siya ang reaction mo undergo og double substitution, if ganing expected ni nga maoy mga product, since dili pa man na siya stable, kinahanglan pa na siya mo decompose into simpler kanang forms like carbon dioxide and ammonia. Okay, so to illustrate, let's have this example. Predict the products of the following reactions. You have lithium carbonate and chloric acid. Okay, so ini ka double substitution na class, si lithium, no, si lithium by the sana kanang ari na siya sa chlorate, no, nya kini ari. Okay, so lithium positive 1, si chlorate, no, charge negative 1. Mo nang mahimo siyang mahimo siyang LiClO3. Okay, so sayop na LiClO3, then hydrogen plus carbonate, yung charge is negative 2, so mahimong H2CO3. Since this is a carbonic acid, maunta niyang kanang kuan, maunta niyang mga product H2CO3 kini mo ni product ani. Okay, since the product is carbonic acid, so kinahanglan siya mo decompose. Unsa galing to mo decompose siya into carbon dioxide and water. Okay, so mo nang this is now the final nga product. 2 moles of lithium chlorate and 1 mole of water and 1 mole of carbon. Okay? So, balance na siya. If you will check, lithium 2, kini 2, carbonate, you have carbon, no? Let's start with carbon. Carbon 1, 1. Oxygen 3 plus 3 times 2, 6, 9, no? 9. Dire, 3 times 2, 6, 7, 8, 9. Check. Hydrogen 2, 2, chlorine 1, 2 day, kay multiply 2 sa dire. Okay, so the equation is now balanced. For this one, no, ito sa ni-erase. Okay, for this one, no, you have ammonium chloride plus sodium hydroxide, no? So, kini may mo pares ani. Okay, so we have Na, positive 1, chloride 1, so NaCl. Then, NH4, positive 1, hydroxide, negative 1. So, na mo NH4, OH. So, mo niyang katong giingon niya nga kumugawas ganing si ammonium hydroxide. Ammonium hydroxide. Mo disintegrate siya into ammonia and water. So, muna ni siya nga you have sodium chloride, water, and ammonia may ma-produce. Then let's proceed with combustion reaction. So, burning, also called combustion, is the rapid reaction of a wide variety of materials with oxygen gas. Combustion reactions of elements can also be classified as combination reactions. The type of reaction is not as important as the product. So, for example, we can refer to the following reactions as combination reactions or combustion reactions. No? Carbon plus oxygen will yield carbon dioxide. Sulfur plus oxygen will yield sulfur dioxide. But the most important application sa combustion reaction is in dealing with hydrocarbons or compounds composed of carbon and hydrogen only. So, we burn methane, CH4, cold natural gas in our homes to provide heat, and we combust octane in our cars to provide mechanical energy. So, in writing your the product of combustion, the product of combustion is carbon dioxide plus water. This is for enough supply of oxygen or sufficient supply of oxygen. Kung kulangan galing ang supply of oxygen, you have carbon monoxide plus H2O. So, when yung mention nga, if sufficient oxygen is present, carbon dioxide is produced. If the supply of oxygen is limited or kulang, as in a car engine, carbon monoxide is the product. So, with very limited oxygen, soot, a form of carbon and water are produced. So, in any case, water is always a product of combustion. Okay? So, to illustrate, let's have this example, right? Which of the following reactions was carried out in a limited supply of oxygen? So, we are asked, no, asa aning duha ka reaction is carried out in a limited supply of oxygen. So, ang una na itong buhaton is to look for carbon monoxide. Kaya nga naman, si carbon monoxide is an indication that the combustion process is kanang incomplete or kulangan ang iyang supply of oxygen. In this case, we have here carbon monoxide. So, kini nga equation or kini nga reaction ang ni-undergo og limited supply of oxygen. Another example, write a balanced equation for the reaction of butane C4H6 in a limited oxygen supply. So, di nga mo siya limited nga oxygen supply, okay? So, mao nang kung limited ganing ang product of combustion is carbon monoxide, no? So, C4H6 plus oxygen, agi na oxygen kay di na mo burn, no? Kung may oxygen will yield limited supply, carbon monoxide plus water. Okay? So, yung mga carbon is 4. So, you write here 4. Hydrogen 6. Since na may 2, ani, you write here 3. Kay 3 times 2, 6. Then, ang imuhang oxygen 4 plus 3, 7. So, you write here 7/2. Again, dili man lagi ta pwede og ang ato ang coefficient is in fraction form. So, we will multiply by 2. So, this will become C4H6 plus 7O2 will yield 8CO plus 3. 3 naman, 3 times 2, 6. 6H2. So, the equation is now balanced. So, the combustion reactions of compounds containing carbon, hydrogen, and oxygen, which include the carbohydrates used for food, also produce either carbon monoxide or carbon dioxide depending on the relative quantity of oxygen available. Example, write a complete and balanced equation for the reaction of sucrose, table sugar, C12H22O11 in a limited supply of oxygen. So, limited supply of oxygen. So, C12H22O11 plus O2, limited supply man. So, your product is carbon monoxide plus water. Carbon 12, so you write here 12. Hydrogen 22. So, you write here 11. 11 times 2, 22. Your oxygen, you have 11 plus 2, 13, no? Here, we have 12 plus 11, that is 23. Tama ba? 11, 23. So, para mabalance, no? Mabalance, we will write here 6. Okay? So, 11 plus 12, 13, 23. 11 plus 12 plus 11, 23. So, balance na. Nasa iyo lang ni 8. Okay? So, that is all for predicting the products of combustion.